for now. So what holds our world together? Well, on the nuclear scale, 10 to the minus 12 centimeters, very important are the nuclear forces. On an atomic scale, up to thousands of kilometers, it's really electric forces that hold our world together. But on a much larger scale, planets and stars and the galaxy, it is gravity that holds our world together. And now you may say, that's very inconsistent with what you just told us, because didn't you tell us that D cancels if you compare gravity with electricity? Yes, however, most objects are neutral or very close to neutral. And so if you take the Earth, it is very unlikely even that the Earth as a whole would have a charge of more than 10 Coulomb. That probably is already an exaggeration. So if I take the Earth and I take the Moon and I put on both a charge of 10 Coulomb, here's the Earth and here's the Moon, and I put, say, just arbitrarily 10 Coulomb here, and let us put on here either minus 10 Coulomb, so they will attract each other. But given their distance, it's almost nothing. The force is negligibly small, but of course, the force of gravity, which is proportional to their masses, wins. And in this particular case, if you take the Earth and the Moon, the gravitational force wins over the electric force by 25 orders of magnitude. So even though our immediate surroundings are dominated by electric forces, including your own body for that matter, the behavior of the universe on a large scale is dictated by gravity. We will use various instruments to measure charge in a quantitative way. And one of the instruments that you will see, we will use it often in the lectures that are to come, is called an electroscope. It's a very simple instrument. In general, it is just a conducting rod. It could be aluminum, metal, and at the end are two pieces of tinsel, two pieces of aluminum foil, and often there is a nice knob here. And if I touch this with a charged object, then because this can conduct electricity, this can conduct the fire, as defined by Benjamin Franklin, if I touch it with an object which is positively charged, then this object will become positively charged. If I touch it with an object which is negatively charged, it will become negatively charged. And you see now here these two very light pieces of aluminum foil will repel each other. And so you will see that this shows a certain angle. And the more charge there is, the larger that angle. So that gives us a way of doing some quantitative measurements. There are other electroscopes which are not too different. Just one central rod, and they would have one leaf hanging there. And when you charge that one up, then this leaf will go out, and if the charge is more, it will go out even further. I don't have an electroscope now here, but what I want you to see that if I charge myself up, and I hold in my hand these Christmas tree tinsels, that in a way, if I get enough charge on me, then these tinsels will spread out. It's an idea that immediately follows from the fact that you get a certain amount of charge, whether it's negative charge for me or whether I'm positively charged, that doesn't make any difference. These tinsels will spread out. And of course, the best way I can do that is by charge myself with the Van de Graaff. And as I said earlier, experiments of this nature are not entirely without risk. And so There's always the possibility, of course, that I don't survive this demonstration. But don't worry, because in that case there will be someone else who will lecture 802, except he is not likely to show this demonstration again. So you might as well take a close look, because this may be the only time you will ever see it. So I will give you some nice light on the Van de Graaff. And it's always a scary moment for me. Sleepless nights about the Van de Graaff. Am I going to turn it on, Marcos, or you have the courage to turn it on? You will turn it on? Okay, hold it, Marcos. This is too close for comfort. You ready? Are you nervous? See you. So look at the tinsels. And try not to look at me, please. Go ahead. I am now a living electroscope. If the weather is cooperating today, and if I had long hair, you might even see that my hair would start to act like an electroscope. We can try that too. Why don't you throw it? Is it working? Okay, well, this weekend make sure you take this nylon shirt off in front of the mirror and enjoy the experiment at home. Don't try this ever.